Welcome everybody. This is our first video for AP Physics. Kind of note help. We're talking about acceleration today. Acceleration is simply defined as the rate of change in velocity. If you remember, velocity then has both size and direction. But what we're going to be talking about today is the rate in change of the size of the velocity. So if we have an acceleration that is 10 meters per second every second, that means that we change our velocity 10 meters per second every second. So let's just say that we have that 10 meters per second, and we have a v sub naught, which means our velocity initial, it's at naught time, of 0 meters per second. And let's say that we do this acceleration for, let's say, 5 seconds. So if we have a 5-second time where we accelerate at 10 meters per second every second, then our final velocity, which is just symbolized without any subscript, would be 50 meters per second. Okay, and if you want to look at a formula, acceleration is delta v over delta t. Acceleration then is v minus v sub naught divided by t that it took to go from the v sub naught to the v. And if we want to figure out or solve for our final v, then we would have t a minus or plus v sub naught equals v. We did a little bit of algebra steps right there. Since our v sub naught is 0, that can be ignored. Our velocity then is our time times our acceleration. And so we can see that our final velocity in this case is 5 seconds times our acceleration of 10, or 50 meters per second. Now I like to use 10 in this first example because it's real easy to multiply and divide by 10. So I got a question for you right here. Let's say that you are accelerating at a rate of 10 meters per second, okay, and you're going to do that for 10 seconds. Okay, so your acceleration is 10 meters per second every second, and you do that for 10 seconds. How fast are you going if your v sub naught equals 0? Well, your v, or your final velocity, is going to be 100. That's pretty easy to do in your head, right? Well, I want to also talk about what happens as far as displacement during acceleration. So if you remember, our velocity formula from yesterday is average velocity is displacement per time. And we also said that average velocity is your final velocity plus your initial velocity divided by 2. That's kind of a special circumstance. And that special circumstance is when your acceleration is constant. Okay, so you can always do your v plus v sub naught divided by 2 if your acceleration is constant, and you'll get your average velocity here. So if you kind of want to look at what that looks like on a graph, this would be your velocity and your time, and you can see that if I start at 0 here, and I have a constant acceleration, now we talked yesterday about what the slope of a line means, and you know the slope of any line, like we said, was, you know, the y's over the difference of the y over the difference of the x, correct? And I said, well, if you want to know what that slope means, all you have to do is look at what the label of the y is. So in this case, the label of our velocity is going to be meters per second, and you just put that in, the y, meters per second, and then our label for time is going to be seconds. You put that in there, and we can see that our slope here is actually then equal to meters per second, or an acceleration. And that is going to be true for every single slope that you ever deal with. You can just look at the y label and look at the x label and fill them in accordingly, and you can see what the label is for the slope value. Okay, so in this case, if I have a velocity time graph, or in any case, if I have a velocity time graph, the slope of that line then is going to be acceleration. Okay, but we're kind of back to where we started here. I want to talk about this just a little bit more. We said that we accelerated at 10 meters per second every second for 10 seconds. Okay, so if we look at this, we'll get this cleaned up just a little bit here for you. If we look at this graph, we can see that if we put this out to 10 seconds, okay, we did the math already. This should be at 100 meters per second, correct? Now, if I wanted to figure out what the displacement was of this, there's a couple things I could do. You'll have to excuse me for that. I had to extend my page, and I wasn't able to in the other format. Because I want to look at this graph a little bit better. Like I said, if I wanted to figure out what my displacement is, it's going to be my average velocity for time, right? And I also said my average velocity here can be my v plus my v sub naught divided by 2. And if we look at this, in our current question, we know that our v sub naught here is 0. Our final v is 100, correct? So if we put that into that formula, our average velocity then is going to be 100 plus 0 divided by 2. Okay, so this is kind of a special circumstance too. Another kind of way we can think about it is average velocity is final velocity divided by 2 if initial velocity equals 0. Okay, that's another way we can figure out our average velocity. So if we want to look and see how this is going to affect our displacement, then we can have our average velocity by the time that it took for us to go from our initial velocity to our final velocity. So in this case, looking at our graph or thinking about our problem, we can see that this is our final velocity, 100 meters per second. Our initial velocity is 0 meters per second. So we know from this graph, our average velocity in this case is 50, right? 100 divided by 2 is 50. And how long did it take us to go from 0 to 100 meters per second? Well, you can see it took us 10 seconds. So our displacement then, following our formula and our understanding, our displacement then is going to be 50 times 10, or our displacement then is 500 meters. Okay, and so that's the way displacement happens when we have a constant acceleration. Now I want to show you another way to figure out displacement. Since we're talking about graphs, we have our velocity time graph, and we'll just make the same graph. It's going to be, 10 seconds and 100 meters per second here for our endpoints here. And I told you the first day or the second day that, the area under the graph always means something, right? And then I kind of told you how to figure that out. Well, you look at what's your area formula. Area is base times height. Do you agree? Yes, you do. Base times height. So, in this case, base, we could use time, right? So I'm going to put time in here for our base. And our height then would be velocity, we could say, velocity, and that equals area. So the area under the curve, under this curve here, is time times velocity. So you know what that is, but do you really know what that is? Well, the other thing with this curve is, this is a triangle, so you really have to take, in this case, 1/2 base times the height, or in this case, 1/2. Now remember, we did something with half earlier too, though, didn't we? Didn't we get an average velocity by taking half of our final velocity? So there's got to be something starting to click here. So if you remember our formulas, one of our first formulas, we said our average velocity is displacement per time. And if we're looking for displacement here, we can see that it's velocity times time. Oh, velocity times time. Okay, so now we know what the area under this graph means. The area under this graph right here is equal to velocity times time. Velocity times time is equal to displacement. So if you were to take, plain and simple, the area under this graph, it'd be 1/2 times our base would be 10 seconds times our height would be 100 meters per second. And you can see that we would get an area that'd be equal to 500. Well, in this case, seconds cancel out, and we're left with 500 meters. So that's another way that you need to know how to determine displacement with constant acceleration.